Hello everyone, welcome to my video tutorial on differentiation. This is part 2 and in this video I'll be covering the concept on stationary points. So let's begin with this. Stationary points refer to those points where the gradient of the function is 0. So the gradient, as you can observe over here, is 0 over here, it's 0 over here and here, okay, also over here. So all these points refer to stationary points. Alright, so the gradient, which means if you differentiate this function, you will get dy by dx as 0. Okay, so now the nature of the stationary points. In general, there are three kinds of stationary points. One is the maximum point, the other is the minimum point, and the third is the point of inflection, which, okay, the third is the point of inflection, but we will not be covering in the CI syllabus. I'll just give you a brief idea about what you can just refer to as neither minimum nor maximum. Okay, so let's discuss about maximum points and minimum points. These maximum or minimum points are also termed as local minima and local maximum point. They are the word local is because this curve has maximum point over here as well and here as well. So this is a localized maximum point, meaning that for this region, and for this region this is the maximum point. Similarly, you have minimum points over here. Now whether the point is minimum or maximum, the gradient function would be 0 for both, and these points are referred to as stationary points as well, or you can term them as turning points. So let's look at a question. You need to find the coordinates of the stationary points on the curve y equals to x cube plus 3x square minus 9x minus 4. So आपके पास equation है curve की. You need to find the coordinates of the stationary points. For stationary point, what you need to do is you need to take the gradient, which you need to differentiate this equation. So dy by dx of this equation would be 3x square plus 6x minus 9, and the differentiation of a constant term is 0. Okay, now for the stationary point, dy by dx would be equal to 0. Therefore you need to find those values of x for which dy by dx is equal to 0. Now you can factorize this equation or use the quadratic formula, and the values of x that you will get are 1 and minus 3. So this means that there are two stationary points available. Now for the time being, we don't know whether these 2 points are minimum or maximum. अभी तक हमें नहीं पता, ठीक है. But the stationary value of the curve occurs at x equals to 1 and x equals to minus 3. In this question you were just asked to find the coordinates, meaning now you need to find the y coordinates as well. So you will have to evaluate y of 1. So when you plug 1 in this, you get minus 9, and when you plug in the value of x as minus 3, you get positive 23. So the stationary points are, let's say the first stationary point is 1 comma minus 9 and the other stationary point is minus 3 comma 23. These are the coordinates of the stationary point. Okay, now let's have a discussion about the nature of the stationary point. Nature of the stationary point means we need to figure out whether the point is a minimum point or a maximum point. Okay, this will be a stationary point. Now we need to determine the nature of the stationary point, and for that what you do is you do the second derivative, meaning you differentiate the function once and then you are differentiating the gradient function again, hence differentiation of dy by dx, which is d square y over dx square. Okay, it's known as the second derivative. Now a maximum function, let's say this is a stationary point where the dy by dx value would be 0, right? Before this value, before this point, the gradient of the curve is positive. Okay, it's an increasing function, the gradient of the curve is positive, and after the stationary value the gradient of the function is negative. So gradient is decreasing. So let's say you find the gradient at this point, okay, and then आपने gradient इस point पे मालूम किया, ये further कम होगा, यहाँ पे the gradient becomes 0, the gradient turns out to be negative, and further the gradient would keep on decreasing. So we will say that the rate at which the gradient is changing is basically the rate of change of gradient is negative over here. It's decreasing. As you increase the values of x, the gradient is decreasing with the increased values of x. So d square y over dx square, the second derivative, is less than 0, hence the gradient is decreasing. So this point will be a maximum point. On the other hand, if you were given a curve and you know that the stationary value is occurring over here, तो यहाँ पे तो gradient 0 है, ठीक है. अब let's have few values before this stationary point, and let's say the gradient came out to be a negative gradient, and as you increase the values of x, the gradient is actually increasing and becoming positive. So the rate of change of the gradient is positive because the rate of the gradient is increasing. So d square y over dx square, the rate of change of the gradient is positive, and that if that is the case, then we can see that the graph obtained is a minimum curve. So in a nutshell, if you have a second derivative coming out to be positive, then it's a concave up graph, meaning this, and the point is a minimum point. And if you have a second derivative, f double prime of x is negative, then it's a concave down curve and with a maximum point. So the nature of the point will be maximum point. So let's look at this question. In this question, you have been given a function and you need to find the nature of the stationary points. ठीक है. So सबसे पहले what you do is you differentiate it and find the stationary points, and then the next step would be to find the nature of the stationary point. So dy by dx would be 3x square plus 6x minus 9. In order to find the stationary point, you will have to place dy by dx as 0. So the equation would become 0 equals to 3x square plus 6x minus 9. factorize it or solve this equation, you will get one value of x as minus 3 and the other as 1. So the next step now would be to find the nature of the stationary point. At this moment we know that the stationary value is occurring at x equals to minus 3 and x equals to 1. So let me call this point as A and this point as B. If I want to find the nature of the stationary value, I have to take the second derivative. So the second derivative of this function would be 6x plus 6. Now you want to find the second derivative at point at x equals to minus 3, and you want to find the second derivative at x equals to 1. So when you will place minus 3 in this expression, you will get a negative value, which is minus 12, and when you will place 1, you will get a positive value. So this means since d square y over dx square, the second derivative, is a negative value when you place x equals to minus 3, this means that point A is a maximum point. And since d square y over dx square is a positive value, meaning it's greater than 0, this means that B point is minimum. So that's the nature of the two stationary points. Achha, so let's look at this question now. In this question, in part 1, you need to find the coordinates of the stationary point on the curve y equals to x raised to the power 4 plus 32x. So the way you will solve this question is, first of all, you will differentiate and obtain the gradient function 4x cubed plus 32. Then in order to find the stationary points, you will set dy by dx as 0. So from here you get x cube as minus 8, and cube root of negative 8 would be minus 2. So the x coordinate of the stationary point is minus 2. In order to find the y coordinate, you will place the x coordinate back in the original equation. So and the value of y comes out to be minus 48. You just have to place x as minus 2 in this equation. अच्छा जी, तो स्टेशनरी पॉइंट तो आपके पास आ जाएगा -2, -48, and that is the answer for part 1. Now for the part 2, you need to determine the nature of the stationary point, and for that you need to take the second derivative test. So this means that you need to differentiate the dy by dx wala function again, and you will get 12x square. Okay, now let's evaluate the answer for d square y over dx square at point x equals to minus 2. So at minus 2 you will get a positive value. So you will say, since d square y over dx square is greater than 0, it's a positive value, therefore the point is a minimum point, and that is the nature of this point. It's a minimum point.